By now, many of us have seen Elon Musk and Ashok Eluswamy having Elon Musk's Tesla Model S drive them around Palo Alto. It's really amazing stuff, and of course, I've done several videos on that already. You can check them out up here if you're interested, and I'll leave a link in the description. But in the X Spaces that happened just before Elon Musk started his live space, he talked about a lot of the back-end details and how much work goes into that. And Andrej Karpathy and other people have also weighed in. And let me tell you, this stuff is really impressive. Let's take a look. Hey y'all, it's Dr. Know-It-All. This is part 3 of a 3-part series. Actually, there's going to be an addendum at the end of this. Yesterday, I asked if people had questions or things that needed clarification from Elon Musk and Ashok Eluswamy's drive around Palo Alto. And there were a number of questions, but actually there's so many good questions that I'm just going to have a whole episode devoted to that. But in this one, I'm first going to go through a few relevant tweets, and then I'm going to turn to the X Spaces, the part that Elon Musk joined. It's about 12 minutes or so. So first, let's start with Tim Zaman, who says that he is part of Tesla's infrastructure team. He said, Tesla AI 10,000 unit H100 cluster goes live Monday. Due to real-world video training, we may have the largest training datasets in the world. Hot tier cache capacity beyond 200 petabytes, orders of magnitude more than LLMs. Join us. So clearly he's saying, come, if you're a hardware kind of guy, come and check it out and see what they can do with this. So a 10,000 H100 computers is a lot of money. And actually incredibly difficult to get. It's kind of amazing that Tesla is able to get 10,000 of these almost impossible to get H100s from NVIDIA. And of course, as I'm recording this on Tuesday, there's a very good chance that this is live already, which is pretty darn amazing. Also note here that they have 200 petabytes worth of hot tier cache capacity. That means very high speed memory that's able to be pulled out, done calculations with, and then put back into memory very, very rapidly. One of the biggest problems with neural network training these days is that the neural networks actually sit there for a long time. The GPUs or TPUs or whatever sit there and wait for data. And so like 90% of the time they're doing nothing. They're just sitting there waiting for data. So having 200 petabytes of hot tier cache capacity is kind of incredible. I have no idea how much that must be costing them. And of course, the data communications and all of that kind of infrastructure just must be absolutely insane. Honestly, I can't even imagine it. I actually wish that they would post a couple of pictures of what this thing looks like, just from the distance. We don't need any super secrets, but it would be pretty darn cool to look inside the bowels of this thing and see what 10,000 H100s plus the data storage plus all the interconnects and all of that stuff actually looks like in a data center. And as Tim, I'm sure very correctly points out, they have orders of magnitude more data than large language models. Language is relatively straightforward to store. It's pretty small. Now, yes, a lot of these LLMs have now gone to multimodal and stuff, but most of that is also still pictures and things. So having all of this stuff be real world video data is pretty impressive. Nat Friedman then asked Tim a question that's well above my pay grade. I'm going to read this, but I don't really understand it that well in depth. If anybody does, please let everybody know in the comments. Wow, 200 petabytes hot cache. Super curious for the details on that. What FS and storage network architecture? To which Tim replied, we've tried them all, multi-vendor, and none are great. We wrote our own, not used, so they wrote their own back-end software here, but hiring a storage architect to make a distributed file system for AI. In other words, who cares about resiliency if it's cache? Just drop a bit of the data set is fine. Importantly, use a separate fabric for your storage, literally a physically independent storage fabric, only way to keep sane, and then adapt all storage formats to play nice with your substrate. Many proprietary file formats ideally suited for our clusters. So I'm just going to touch on this blue highlighted part. Who cares about resiliency if it's cache? So remember, this is cache memory. This is the temporary storage. This is the stuff, 200 petabytes of temporary storage. Anyway, you pull stuff in, it's just sitting there. It gets worked on, it gets spit back out, and then it goes back to main memory again. The whole point is to be fast. It doesn't have to be backed up. It doesn't have to be resilient. If there's a power glitch or something like that and it fails over, you just reload it, right? It takes time, but it's no big deal. So clearly that's what they're talking about here, and that's a rather brilliant move not to back up something that's designed just to be cache storage, even though it's that large. As for the rest of the post, I'll let somebody else maybe in the comments talk about that who knows more about this than I do. And then let's turn to Warren Redlick asking a very reasonable question. Does version 12 of full self-driving software prove that George Hotz was right and labeling was unnecessary? To which Leeloo Dallas said, no, it proves Andrej Karpathy was right. Iterating to software 2.0 was the successful path. Starting with end-to-end is not realistic, and Tesla will never be 100% end-to-end. There will be software 1.0 rules around changing gears. So one quick point about this, there are no gear changes in Teslas, so that's not realistic. I don't know if that was supposed to be metaphorical or something, but the idea is that there is something, although I disagree with that because I think it really is end-to-end. Now, there is probably traditional software 1.0 code that glues different neural network architectures together, but I believe that the control systems are actually almost directly output from the neural network outputs. Anyway, when you're on X, you never know who's going to respond to your posts, so Andrej actually responded to this. Didn't expect real top to drop from Leeloo Dallas. I always saw it as a gradual progression of software 2.0 eating through the stack, as I showed in my talks. I've done many videos on that. In fact, I'll put a playlist up here so you can check it out if you're interested. I think starting from end to end is ineffective because the training signal is too few bits per input example. Video with on the order of billions of pixels and streams into an order billion parameter network, and you're getting just a few bits of supervision, means you'll have to train your network for an impractical amount of time or impractically many examples. Supervised learning is a very effective source of useful bits. This pre-trains your neural net so you can later fine-tune it with reinforcement learning end to end. Even once you have end-to-end, in my opinion, any realistic self-driving car deployment will demand a vector space stack because sometimes you just want explicit control. In other words, if a regulator in some country comes to you with the demands around time distance for various maneuvers, say a stop sign, you just want to be able to implement that. A vector space stack gives you a valuable dictionary over scenes, which helps a ton with various data triggers, data science, etc. The ability to both source training data and evaluate the performance of the system. And I wouldn't be surprised if it's involved in also shaping the reward function for reinforcement learning. For these reasons, I never saw the two at tension pulling in different directions. I saw the explicit vector space stack as a precondition to the end-to-end stack, and as something that will stick around even if a lot of the driving gradually shifts to end-to-end mode. So the end-to-end project has been alive and well inside the team for a long time. Super exciting that it's actually starting to look quite capable. So the really big point here is this sort of second paragraph, which is that it's ineffective to start with end-to-end. Many people are going like, well, wait, why didn't they just always use end-to-end? And as Andrej says at the end of this post, they have been using end-to-end internally. It just hasn't worked before. You have to get a neural network architecture, and not only that, you have to get it trained relatively close to what you want it to do before you can turn it loose for end-to-end with something as complicated as the real world. In other words, what he's talking about in this paragraph up at the top is that if you start with completely randomized weights, the reward function is so far away from where these weights are, and the rewards are so sparse that the neural network basically cannot converge to an answer, at least within a practical amount of time. So you have to sort of cheat it and push it in the right direction and get the neural network weights relatively close to where you're going first, and then after that, you can turn it loose with end-to-end and not have data labeling and stuff. So it needs to get close with the traditional methodology that they were using, then you can allow end-to-end to really come in and shine. But if you don't have those initial weights relatively close to what you want, it might take the age of the universe or something like that, or, trillions of examples of driving for it to be able to converge, and that would just take too long. And then Andrej responded to himself, and this actually tails right into the X spaces, so this is perfect. What a segue. Worth expanding on is that an important caveat to keep track of in all this is what runs in the car versus what runs in the background. In other words, the whole explicit stack might be alive and well, but over time move to back end, used to, number one, tune the data distribution, and two, modulate the loss function, and in this way, quote, get distilled into pure end-to-end test time networks. That's the dream. So as I said in my previous video, you want to keep the end simple. You want the KISS methodology. You want to put all of the complicated stuff on the training, back-end, data collection. All of that can be very complicated and gnarly because you can throw billions of dollars worth of compute clusters, for example, 10,000 H100 GPUs at the problem. What you want is to make it really simple on the inference end, and that's clearly what Tesla is working on. They're trying to create an end-to-end back-end inference network that the computer in the car can use that is relatively simple and lightweight and can run very quickly. And as Andre says, that's the dream, and it looks like Tesla is getting pretty darn close to it. With that preamble, let's turn to the X Spaces, the part of it where Elon tuned in and talked about some of the back-end stuff. So the X Spaces is just people talking, so I've layered over the full self-driving beta 12 example, so you'll notice the video is not that fantastic, but anyway, it was to give you something visually to look at while he's talking.
Hey, Elon, are you on V12 right now?
Yeah. So, yeah, I'm on the V12 beta, which is just a full AI end-to-end, push on in, pulls out. It's pretty amazing. It's driving very well, but on 280, so it's driving down 280. So right now, I think it's somewhat distinguishable from the production autopilot production FSD, where it turns out we'll have, because it's actually pretty easy to drive on the highway, relatively speaking. But we're going to turn off the highway in about just 10 minutes, and then we'll be in Palo Alto. And so we'll go cruising around Palo Alto. We might try to find Dutch house and challenge him to a flying if possible. It's probably traveling, and it's like 8,000 houses in Palo Alto, so I don't know which one is that.
I love that part of the memes, Elon. Well done.
Yeah.
So you are delighted.
Yeah, that last word. It say FSD12.
You shortage
Photo movements out to hand and photo movements out, and so
controlling everything over to neural nets.
well, I mean, this is basically how humans work. So
Hell yeah, this is so awesome.
yeah.
So could you give us any more commentary, like architecturally? I saw the CVPR conference and stuff, but why go end to end? What's the advantage of moving control and everything over to neural nets?
Well, I mean, this is basically how humans work. So we're sort of photons into motor movements out to hand and foot movements out, and so that's kind of what works best, as opposed to injecting a bunch of heuristics. Now, I should say that this does take a lot of training compute. Your training I should say that they should not have a bunch of heuristics.
213. So again, just as a setup, he's talking about
Could you give us any more commentary, like architecturally? I saw the CVPR conference and stuff, but why go end to end? What's the advantage of moving control and everything over to neural nets?
Well, I mean, this is basically how humans work. So we're sort of photons into motor movements out to hand and foot movements out, and so that's kind of what works best, as opposed to injecting a bunch of heuristics. Now, I should say that this does take a lot of training compute. I think we will probably spend on the order of $2 billion this year on training compute. A bunch of that is acquiring hardware, so that'll last for some number of years. So it's, but we'll probably spend a similar amount next year, if actually more next year probably. So it's not like walk in the park here. It's a lot of data and a lot of training, but it's a very few lines of actual code. So it's really quite kind of remarkable. We obviously have a proof case in the form of humans that use a biological neural net and eyes to drive, and so cameras and digital neural net is kind of the solution to is the correct general solution to self-driving. Now the thing that's kind of a little weird is that it's actually hard for the car to explain what it's doing, but then the same is true when you are, say, driving in a taxi or an Uber or something. You don't actually know what the driver is thinking. You just know what the driver's track record is, 4 or 5 star or whatever, and that they have a lot of experience, and so you kind of trust that experience that they'll drive well. But you actually don't know for sure when you're in a taxi or whatever that that they're going to drive well. That's kind of how it will be for FSD 12.
So I think that was Robert Scoble that actually asked the question. It was a little bit unclear because it wasn't highlighting the people. But anyway, Elon responds to this, as we've already talked about in the previous videos, about the advantages of end-to-end neural networks and the fact that you can get rid of heuristic code. In other words, you can get rid of if-then statements explicitly programmed by programmers for every single eventuality. An end-to-end neural network that has its own world model is going to be much more robust than that. And that's exactly what he's talking about here. And then Elon starts talking about the compute power that's needed to make this happen.
Now, I should say that, this does take a lot of training compute. I think we will probably spend on the order of $2 billion this year on training compute. A bunch of that is acquiring hardware, so that'll last for some number of years. So it's, but we'll probably spend a similar amount next year, if actually more next year probably. So it's not like walk in the park here. It's a lot of data and a lot of training, but it's a very few lines of actual code. So it's really quite kind of remarkable. We obviously have a proof case in the form of humans that use biological neural net and eyes to drive, and so cameras and digital neural net is kind of the solution to is the correct general solution to self-driving.
So Elon talks about how remarkable it is that this works, but you also hear him talking about how much this is going to cost. So he's saying Tesla's AI, just their AI division this year, is going to spend about $2 billion on hardware for compute. And at a rough guess, that 10,000 H100 cluster with all of the networking and storage and stuff is probably about 500 million at a guess. So that's like a quarter of their year's budget just in that one data center. So that's a pretty huge data center. But anyway, he said they're probably going to spend more than that next year. So this is not something where they're like, oh yeah, we got this and we'll just hold on to it for 5 years and then we'll be fine. They're working as fast as they can towards that 100 exaflop bar that they've set for themselves by the end of 2024.
Now, the thing that's kind of a little weird is that it's actually hard for the car to explain what it's doing. But then the same is true when you are, say, driving in a taxi or an Uber or something. You don't actually know what the driver is thinking. You just know what the driver's track record is, 4 or 5 star or whatever, and that they have a lot of experience, and so you kind of trust that experience that they'll drive well. But you actually don't know for sure when you're in a taxi or whatever that they're going to drive well. That's kind of how it will be for FSD 12. So like really, even like the rendering of what's on the screen is an approximation of what the car is thinking, not exactly what the car is thinking.
So let's pause on this for a second. If you recall from the last video, the car itself has learned from watching videos without any access to language or anything, how the world operates. So it doesn't know how to read. It doesn't know English or German or whatever. It doesn't know how to describe what it sees. It doesn't have words for car or road or traffic light. It just understands what they are and it reacts to those things. So there's a weird sort of problem, which is that it sounds like what Tesla's having to do is sort of fork off a piece of that data and estimate what the thing thinks it's seeing in a more human readable format. So what we're actually going to be seeing in the visualization in Full Self-Driving 12, the thing that actually shows up on our screen, is going to not be exactly what's going on internally with the car. I think there was a lot of misunderstanding where people didn't understand what Elon was saying here. He's not saying that the Full Self-Driving doesn't know what it's doing. It knows what it's doing. It just can't explain it to us. It would be the better analogy would be if you went to a country where you don't speak the language and you got an Uber driver and they drove you someplace and you had no way of communicating with that person. All you could do is just look around and go like, well, it looks like they know what they're doing. They're driving correctly, things like that. So effectively, the Tesla Full Self-Driving screen, the thing that you're actually seeing, the display, is just a guess by another subsystem, is what it thinks the main system is understanding the world as. So that's really, really interesting. And there could be some really funky cases if and when I get version version 12 of the software someday, I'm going to definitely look for cases where the car visualizes something that is different than how it behaves. Anyway, that's a really cool insight, and it's also something that makes perfect sense when the car is being trained without any labels and without any access to language. It's just learning on its own, and it has no way of really communicating those concepts because it's learned its own vocabulary, essentially. It has no way of communicating that with the outside world.
But it works really well, and it's super smooth. So,
Wow.
Yeah.
You know, Elon, everyone's been talking about the GPU shortage. NVIDIA just reported monster earnings, and
Yeah,
you've said that FSD is compute
it
constrained.
is.
What do you mean by that? And what will Dojo do to help that?
Well, we do all of our training, or almost all of our training, I should say, on NVIDIA hardware. We're also bringing up Dojo, and we're doing some amount of training on Dojo, and we'll do an increasing amount of training on Dojo. But we have bought a lot of NVIDIA GPUs, and we intend to continue buying NVIDIA GPUs in addition to Dojo. So, it seems like the world is going to be very compute constrained for a while. With for and like I don't know, I think like kind of like I think almost all of the data centers around the world will over time be AI instead of conventional CPUs. Or most of the, like if you were to say like what percentage of the energy is being used for neural nets is going to over time I think be probably 80-90%.
Wow.
So I think that's why NVIDIA has such a high market cap, is that people see demand being very substantial for a long time. So there's room for both NVIDIA and Tesla Dojo, because the demand for neural net training and inference will be so high. It is so high.
So you can hear here that Elon specifically says, Dojo is going to be great and they'll bring it online, but it's not enough by itself. And clearly they're purchasing as much NVIDIA GPU hardware as they possibly can. And in the near term, in the next year or two, he calls it silicon constrained. In other words, they just don't have enough cards. They don't have enough bandwidth. They don't have enough all of this stuff. That's the near term thing. Then Elon starts talking about the medium and long term, and that gets really interesting.
Although I do think that we're trending towards, this year there being obviously a severe silicon shortage this year, but then at some point this will become, the choke point will be voltage step down transformers, because you still have to go from.
It's already happening. People were telling me today, huge wait times on transformers.
Yeah, I mean, that's the irony is that you need transformers for transformers. So it's like, a GPT is most of the compute is autoregressive transformers. The neural net, like the software version of transformers, and then you need voltage step down transformers to run the neural net software transformers. So anyway, transformers for transformers. Indeed there is a shortage of the lead time for voltage step down transformers is already, I think, on the order of a year and getting longer. And that's not an industry that's used to rapid change. They're used to pretty steady state stuff. And then going beyond that, I think there will be an electricity shortage. So just generation capacity, especially if you have if you need the compute to be in one place, which for training you need the compute to be in one place, because the GPUs, which is actually the wrong word, the Google term is actually better, TPU, a tensor processing unit. GPU means graphics processing unit, so we're not doing graphics. In fact,
Yeah, absolutely.
the H100 actually, the H100 technically has a VGA port for boot up, but it has no actual high bandwidth graphics output capability. So it's weird to call something in graphic a GPU that when it actually can't do graphics.
All right, so first of all, it's kind of fun when Elon cracks himself up. He clearly cracks himself up about the fact that GPUs don't have graphics capabilities, which is true, and then about the transformers to do transformers. And so anyway, it's amusing to listen to him laugh about that. But basically what he's talking about in the medium and longer term is that the big boxes, those step-down transformers that take the high voltage line electricity that's being, sent across the country, steps it down to the voltages that these data centers can use. I didn't even know this, but apparently there's a huge shortage of those things. And that's going to become a major bottleneck in the future because you can't put you can build a data center, but you can't run anything until you can get the step down transformers to transform the high voltage electricity to lower voltage that you can actually use in these data centers. And then of course, long term, it's electricity generation. And yeah, we'll have solar and we'll have diffuse energy generation for houses and for smaller projects. But for big things like data centers where all this stuff has to be all together, those need a huge amount of power that comes in from a centralized source. So that is going to be a big challenge, especially with, companies not building big coal power plants, not building nuclear anymore, all of that kind of stuff. That will become a problem. He didn't give timelines for this, but I would guess transformers will be an issue in the mid 2020s and maybe electrical generation in the late 2020s into the 2030s.
I've been in a data center at Google, and they had a square foot of data center space would have pizza box after pizza box on top of each other with no monitor, right? What does it look like to have like 5,000 H100 cards in a data center?
Well, at Tesla, we're bringing up a 10,000 unit H100 cluster right now, actually. And by the way, it's not a trivial thing to bring this up. It's not like, hey, turn on the machines and everything just works. It's we're going 24/7 on this, and with some very competent people, and it's a struggle to get 10,000 H100s to work, like very difficult, and to get all the networking to work and the cabling.
Are you using NVIDIA's networking solution there?
For this system, we are using InfiniBand, but
Nice.
but and this is somewhat an esoteric debate of like what's better, like Rocky, which is basically Ethernet, advanced Ethernet, or InfiniBand. I think the general trend for, if you say like much larger scale things, might be more towards Ethernet, or very high speed Ethernet, which is ROCE, Rocky. And there's also a shortage of InfiniBand equipment. In fact, that's often more of a shortage than the GPUs.
Wow, I didn't know that.
Yeah, so for training, you need a dense cluster of computing. There's a massive amount of communication between the GPUs, or really the neural net computers.
So just like Tim said in the X posts earlier, you hear Elon talking about the fact that you don't just buy these racks of H100s or A100s or whatever it is. You don't buy them, you don't plug them in and they just fire up and all of a sudden you're able to work on this. There is a huge amount of stuff. There's all the interconnects, there's the communication, there's the data storage, all of that kind of stuff. And then step down transformers and electrical generation, because all of these things have to be combined into one very, very small footprint. And of course, air conditioning and all that other kind of stuff. So there's tons and tons of stuff that goes along with building these gigantic GPU data centers. And interestingly enough, Elon said that he believes that most of the compute power in the next several years is going to be devoted to AI. In other words, it's going to be compute devoted to software 2.0 rather than compute devoted to software 1.0. And then Elon turns to inference in the actual vehicles themselves.
For inference, you don't have to, inference you can run on a, like, I don't know, like an 8-node stack or something like that, or even less. Just like in the car, we're running inference with basically 100 watts, 100 watt, and we'll run inference at 8-bit.
So again, Elon talks about how the Hardware 3 board is actually only 100 watts. And to put that in perspective, before LED lights and stuff like that, the just standard light bulb that you would, screw into the light outlet in your house, that was like 100 watts. So it's basically running for the same amount of energy as one of those light bulbs. That's amazing. And he also talks about how they they reduce the resolution of the numbers in order to make this operate as fast as possible. If you're interested in multi-resolution floating point numbers, you should definitely check out this video from a couple of years ago, because Tesla published a research paper about a configurable floating point 8-bit number system that's really remarkable. And I strongly suspect that's one of the reasons why their computers are able to operate at such high frame rates when they're only running at 100 watts. And then Elon gets into Hardware 3 versus Hardware 4.
Is that Hardware 4 100 watts?
Hardware 4 is more. So
Are you going to be driving a Hardware 3 or Hardware 4 car today for the live
this
stream?
is Hardware 3.
Oh, okay. Is Hardware 4 not supported yet?
Not yet. It will be.
Does the higher resolution pose a challenge with the data set and everything? How do you manage that?
We do have to retrain in order to use the high resolution, because of the fact that as photons enter controls out, that photons are different. You're getting a different bit stream with the Hardware 4 cameras than with the Hardware 3 cameras.
So this has confused a lot of people, so it's worth breaking this out. Hardware 4, the cameras are different with that entire system. And what that means is that the actual field of view, the color gamut, the dynamic range of the images, all of that stuff is different. And what that means to the neural network is that that's a completely new signal coming in. Neural networks do not see images like us humans do, right? So I can show you this nice Cybertruck thing, and if I showed you this with a different camera, you would still recognize it as the same cup. You would just be like, well, that's a different camera taking the same picture of the same object. But for a neural network, if it sees it with different pixels coming in, it doesn't understand that as the same thing, which means that the neural network has to be re-fine-tuned. You have to grab the data from the Hardware 4 cameras, you have to re-fine-tune Hardware 4, and you have to export that full self-driving beta. Now, I gave myself a pat on the back in yesterday's video where I said that I had predicted that they wouldn't have Hardware 4 beta until the end of this year, and no sooner did I do that, and it looks like 11.4.4 is now out on Hardware 4. So my rationale for the reason why Elon says the Hardware 4 is going to lag for the next 6 months is that they don't have the amount of training data. They're focusing on Hardware 3, and the photons are just different with Hardware 4 cameras. But Tesla, as always, is moving faster than I thought they would. So they've already got a basic solution to this done. So anyway, at least I got the reason right, even if I got the timing wrong.
Yeah, one last question, Elon. In FSD 11.4.7, they had the side blinker camera, and people noticed it started looking better. How did you achieve that? Is it just better post-processing or something like that, or maybe something neural-based?
We can do a lot of post-processing. Yeah. So in fact, yes, we did improve the post-processing.
So this is something I've seen on X a lot. People are doing before after pictures with 11.4.6 and 11.4.7 and showing that it looks different. I think that is a post-processing thing. I think that's what Ashok said. You couldn't quite hear, but I believe what he was saying was that they just fixed it up and prettied it up so that it would look better to us humans as we would look at the image. So this really has nothing to do with the driving. It just has to do with making it look better for people.
So the thing with FSD that I noticed since I've been using it for God knows how long now, that there's two very distinct variables. There's a safety variable and there's like the comfort confidence variable. And I'm wondering, how much are you seeing with V12? Because we know that the software is super safe. I feel very safe using it, but there's like these little moments where, say, somebody that's new to the software is like, oh, that was kind of inhuman. Oh, that was weird. Is V12 making significant improvements on that side? I would love to hear a little bit there.
Yeah, well, I mean, you'll just be able to see it. Because I'm literally just going to... I guess what I'm going to do is, like, we're in Palo Alto. I'm just going to drop random pins on the map. Just, like, scroll on the map, drop a pin, then drop another pin, then drop another pin. So it's not, it's not like a pre-programmed route. And we'll just see what happens. There's a reason we haven't released this to the public is because we, there's still times when it goes wrong, but you'll see that it's extremely smooth. I mean, it's very, very smooth. It's not very tricky
I
at
can't
all.
wait to see it.
Yeah.
So that last question was asked by Farzad, and by the way, I'm going to be talking to him, I believe, tomorrow, so stay tuned for that episode. That'll be a lot of fun. We're going to get into this, I'm sure. But anyway, he asked about the comfort versus critical safety thing, and there is a critical safety intervention that happens during the full self-driving beta 12 drive because they had to stop because the car was going to try to run a red light. And of course, that's related to the very early developmental nature of full self-driving version 12. But for the rest of it, the smoothness aspect, it sounds like version 12 is going to be much, much, much smoother than version 11 has been. And the main reason why is, again, because it's learned from the way that humans have driven. And nobody really talks about it. Again, I talked about this in yesterday's episode, but the inertial measurement unit, the IMU that's inside the car, is responsible for understanding the acceleration and the jerk, like the jerkiness of driving the car. And you can punish the car for driving in ways like that. And also when humans drive a car, you can say, oh, that was very smooth. Notice how there wasn't a lot of jerk as the person slowed down to the stop sign and then accelerated away. So the car can learn from the IMU as well as from watching videos, and it can figure out how to drive smoothly. But that is going to be a major factor. If you want the normal person who is not like a beta tester and stuff to be comfortable with a vehicle like this, it can't be like going like, driving around crazy like that. Even if a human being does that, our son's learning to drive, and once in a while he'll do kind of a violent maneuver or something, and it's like, well, so it's the same thing as the car doing that. You want the car to be as smooth as possible so that the person in the car is super confident that the vehicle knows what it's doing and you don't even really pay attention. The last thing you want is the car, jerking around and making the person thrown around, uncomfortable, car sick, whatever those kinds of things are. All right, so that's what I've got for you. You can see that there is a huge amount of back-end work being done by Tesla to make all of this stuff happen. That back-end work, they're moving more and more and more of the traditional C++ software 1.0 code onto there, with the effect that they're able to keep reducing the size and the complexity of the neural network that's actually in the inference computer. And that allows the inference computer to run at over 36 frames per second. It allows it to be very lightweight. It allows it to be comfortable. It allows it to drive like a human being does. So Tesla's ability to bifurcate this problem into the training problem and the inference problem and separate that out and put all of the extra work into the training side of things is really making a difference now when we get to version 12 of the software. And of course, whether you have hardware 3 or hardware 4, hopefully by the end of the year, we will all be driving version 12 of the software ourselves. All right, I hope you enjoyed this episode and found it fun and interesting and thought-provoking and a bit geeky. If you did, please do like it so other people can find it. And of course, consider subscribing for more of this kind of content. As always, a huge shout out to my patrons on Patreon, my YouTube channel members, and of course, my ex-subscribers. Thank you all so much for supporting the channel any way that you can. And of course, if you want to join any of the teams, just check out the links in the description. And if you're interested in a whole bunch of really cool merch, check out our merch store. Link is in the description. We have TeslaBot t-shirts, the Tesla meme t-shirt, Success is a Possible Outcome, 4680 battery cells. All of that stuff is on t-shirts, mugs, tumblers, and on and on. So check it out. And finally, don't forget we are both Tesla and Amazon affiliates. If you look in the description, you can see how going shopping for a new Tesla, a solar roof, a Powerwall, or anything on Amazon helps out the channel. In the meantime, I'll see you in the next one. Bye-bye.